Good morning, everyone. Happy Friday, first of all. Thank you for joining us in the finale, the grand finale for reInvent. I see some celebrations there, which is great. It's also great to meet the most committed and dedicated set of builders at AWS. So thank you for making it today. Quick introduction. My name is Amit Alampalli. I'm a product team manager at AWS. I've been around for about 7 years here. And I'm very excited to host a session today with Ajay. Quick introduction.
Sure. Ajay Gupta, I lead the technology and the architecture team at Transaction Network Services, which is a Koch company. And we work closely with AWS on migration to cloud and modernization.
Yeah, and today is one such example case study from the TNS experience of migration of the EMR workloads. It's a really fascinating application actually, and I'm pretty sure most people in this room, pretty much most people in the room, have benefited, in one shape or form. And a quick hint: it's about your mobile phone, and I'll leave it at that. And we'll have to wait for Ajay to come back and tell us all about it. A quick roadmap for the session today. We're planning to spend about 40-45 minutes on the content and about 10 minutes of Q&A at the end. And I'll kick off the session to talk about some of the broader data and ML landscape, including things about the challenges of running ML workloads, some of the best practices we've seen, and the role of AWS Countdown Premium. It's a relatively new service in AWS and how it sort of helps navigate some of the challenges in ML ops. And then we switch on to Ajay to talk about the TNS case study of modernization of EMR workloads, and some of the technical architecture, then some of the learnings along the way, and what are the next steps they have planned for the modernization going forward, and a couple of call to action resources. Quick show of hands. I know most folks here are obviously engaged in ML workloads. Just quick show of hands. How many of you are in some POC stage of ML workloads? I see a few hands. How many of them are in production? Not as many. So, there's a good reason for that. I mean, there's a lot of ducks that you have to get in your row before you can bring an ML workload from ideation to production. And you need to figure out the use case. You have to have the ROI in place. And you have to validate the model. You have to build and validate maybe a single model, maybe multiple models. You have to make sure you have to have the right infrastructure, the monitoring in place. And monitoring is not simply about performance and CPU utilization anymore. You have to think about data drift. You have to think about bias. You have to think about explainability. All of these factors are over and above a traditional workload. And therefore, what we find is that getting business value consistently over a long period of time, maybe you can sort of have that working for a period of time, but for an extended period of time is quite complex and challenging. And based on research, only 15% of the time folks spend on training and hyperparameter tuning. Rest of the time is undifferentiated heavy lifting, as Matt calls it in his keynote, undifferentiated muck, and that's quite challenging. And imagine this level of complexity while running workloads on-prem. It doesn't sort of simply add an extra layer; it multiplies the complexity manyfold. Some of the common feedback items we hear from customers include long deployment cycles. Production upgrades are fairly complex, which also trigger a bunch of outages during upgrades, high fixed costs, and so on, and a long list of challenges which we hear from customers. Therefore, it's not super surprising that we find a high failure rate among ML workloads. Based on Gartner's research, about 46% of workloads never make it to production. And even if among those that they do, about 30% of projects after production are abandoned. And it takes on average, about 11 months to get value out of these workloads. It turns out the overall success funnel is fairly narrow. So the key question over here is to how to solve these business problems that we're tackling without being bogged down by technical complexity. And an important part of the solution, we believe, is to have an effective ML ops framework, a framework that brings together people, process, and technology to standardize and to automate the entire life cycle from model building, deployment, and governance. So now, how do we think about a framework like that? We believe there are three key design principles to consider in bringing this framework to life. The first one is around separation of AWS accounts. The idea over here is to make sure you have different, I suppose, sandbox, so to speak, for development, for staging, and production. And the goal is to make sure, in specific for situations where you have data sets with personally identifiable information, which is an example of what TNS has today on the AMR workload I mentioned earlier. It's quite important to have a separation of accounts. And also it also helps you make sure that the defects are not propagated from one environment to the other. The second principle is around versioning and lineage. This is across data, code, features, models, and the intention over there is to make sure you have clear auditability and traceability, specifically around for situations where you have regulated workloads, because you have to, at times, recreate historical recommendations for audit purposes. And third is about automation, again, across the board. We're going to see some examples of automation, both in some examples over here in the reference architecture and with TNS architecture. Cool. I mean, the good news is we don't really need to have the perfect solution on day one. Instead, we had to think about this as a journey along the way, and we have sort of captured three different phases of maturity of MLOps. One is around, the level one is around having repeatability and predictability in your pipelines. And over here, you may start small, focusing on automated pipelines just for data processing and for building to begin with, and some standardization of modules for reusability. The goal is to sort of reduce sort of more technical outcomes over here, not necessarily business value yet, is to reduce your time to build and deploy and to improve your innovation cycles. Second, to build on that is to have a reliable phase, and over here, the goal is to have further integration of CI/CD pipelines and having a more robust monitoring and validation process. And the goal over here is to reduce your defect rate so you have higher confidence in your recommendations on a consistent basis. And finally, the highest level of maturity is in sort of building a more fully automated and integrated ML operations framework. And over here, the goal is to have enterprise scale replicability and standardization using templates and standardized projects to quickly spin up multiple teams working together in a repeatable format. And the goal over here is to reduce your business value from several months rather, to a few weeks or days. Quickly touch upon a few tools as well. I mean, we thought about the principles, we thought about the phasing. Next, we think about the tools that we have at our disposal to make this, to able to bring the framework together. Very quickly, I'll touch upon a few of them across the life cycle. Let's look at the initiate phase with tools such as SageMaker Unified Studio. I mean, this brings together functionality from a range of different AWS services, analytics services, and data services, including Glue, Athena, and EMR in one single place. The goal over here is to reduce your tool sprawl and to reduce your overheads in during the build phase. And the other example is I want to pick on is ML Flow. I think with the new releases, especially in reInvent, basically we have now a managed and serverless ML Flow as well. That really reduces your overhead. It's in a serverless way. You don't really have to manage your own servers or configuration, because entirely serverless features that have been launched at reInvent this year. For those who do not know, I've just touched upon ML Flow, but it's essentially a great tool for you to be managing experiments and tracking them across the journey with ML Flow, entirely serverless. And we also have, obviously, the big ones such as the Model Monitor, again, a fully managed service to reduce the overhead and processing time. And the goal over there is to monitor the quality of your models for different considerations, including data issues, data quality, explainability, and also data drift. So these are some of the tools that you have at your disposal. So we have covered some principles, some phases of how we think about this, some of the tools that you have to consider in bringing it all together. An example of that, how all these things come together in a reference architecture. I know there's a lot of things going on over here, but I will just focus on a couple things. One, as you can see, the separation of accounts. There is data account, there is dev account, and a tooling account to sort of provide that level of separation and privacy, of data privacy. And second area to focus over there is the testing and validation approach over there with an approval framework on the right-hand side. And the goal with approval framework, you could either do it manually to begin with, but you can also have automation around that using Event Bridge, which triggered based on the updates to your model registry, with your any sort of updates to that and changes to that will trigger the approval workflow and also trigger a CI/CD to the staging account. So you could potentially start with the manual approval process, but then extend it further to automate it based on the Event Bridge events with your changes to the registry. That's an example of a reference architecture to think about in the sort of reliable stage of your maturity, looking at some of the tools which we saw and the principles we saw earlier to bring it to life. Slightly more complicated, but the point of the slide, I don't want to go into too much detail here. The point of the slide is to say, as much as we have to think about the infrastructure, there is the parallel universe of data. This is like if you watch the show Netflix, Stranger Things, there's a parallel universe upside down. And so you have to think as much about the upside down as much as you think about your real world as well. And the key point over here is to make sure you have your data pipelines automated so that you are irrigating your pipelines, that you have separate data sets in each of those accounts. All right, switching gears from the reliable phase to the scalable phase. Over here, I think the key difference between the previous architecture to this architecture is around basically advanced, and what you see on the left-hand side, the small box on the left-hand side, which you see over there, and that's about the analytics governance account. That's the key difference over here. I mean, there's the ones on the right-hand side is more of a repetition from what you saw and building on top of the previous stage. In the scalable stage, the key difference is the left-hand side box, which is sort of the advanced analytics and governance account. And the goal of this account is to host the repositories, the infrastructure code of the ML accounts, VPC subnets, endpoints, buckets, the IAM policies all together in that single account, and the service catalog to essentially automatically deploy CloudFormation stacks on demand to spin off these other rest of the environment with using a single service catalog over there. And the goal is to standardize this architecture so that you should be able to spin off such environments on demand for various different teams. And the goal is to, when you have tens, maybe multiple teams working together, they can all share a common language, common architecture, spun off from a single project instead of replicating each single time. So with that, this is sort of the highest level of maturity is what we've seen from a framework perspective. A few additional resources for some of the topics which we've covered today is from best practices which we captured For ML governance, the one I referenced earlier, serverless ML flow, and GenAI Ops foundations. Some of additional resources for you to think about along your own journey. Cool. Switching gears a little bit, talking about AWS Countdown for a quick 5 minutes before I give it to pass it on to Ajay. So as we were seeing, it's a fair amount of nuance and fair amount of I suppose configuration required for you to be able to get to a completely scalable MLOps framework. And to help with that, AWS has launched relatively recently AWS Countdown Premium to offer a detailed level of technical guidance to accelerate your journey of maturity across the stages. Very, very quickly, what is Countdown Premium? It is essentially a guidance service to help you along the entire journey from planning all the way to hypercare. It's a technical service, and what it offers is a dedicated engineer, CDP Countdown Premium engineer, to work with you embedded in your teams all the way through your journey. In addition, it offers tooling templates, runbooks to work alongside with you to be able to guide this journey along the way. Very, very quickly, so far it covers a bunch of different use cases, migrations, including things like, in addition to the ones, data migrations also covers migrations from such as VMware and databases. Modernizations include other examples such as IDE, which is Windows to Linux as a modernization example. And then a big focus, growing focus is around large ML workloads, including implementations of GenAI on Bedrock or SageMaker or agentic workflows. About 400, 500 customers so far, and we've been fortunate to have a strong positive feedback so far in terms of the customers who adopted Countdown Premium. A typical life cycle in terms of what to expect in an engagement of this nature. I mean, this is obviously illustrative, and it is dependent on the use case. Some use cases are as short as 1 month. Sometimes they go all the way to 6 months to 12 months, depending upon if it's a VMware or a mainframe modernization. So it's use case dependent, and a positive feature is the flexibility of time frame. And the goal is to meet you where you're at in terms of your journey. Launching at re:Invent, Countdown is integrated into the AWS Transform, which was part of Matt's keynote earlier in the week. And essentially, Countdown over here with AWS Transform enables human in the loop. So as you are progressing with your migration, let's just say a mainframe modernization and code transformation, so the goal is that the experience essentially allows you to engage CDP engineers directly in your workspace, so within the context of your chat experience over there on the right-hand side that you see. And you don't really need to navigate to AWS console or management console. You don't really have to create IAM permissions or anything like that. You can all of the interactions and the guidance is available as a part of the AWS Transform experience. Some more launches we've done with well-architected framework. I'm not sure how many folks are familiar with the AWS well-architected framework. Anybody here? A few of them. Cool. That's great. So as some of you are aware, a well-architected framework gives you best practice guidance along 6 different pillars. And these pillars are across sustainability to performance. And these are not sort of general advice, but very specific to the nature of the workload that you're working on. And at re:Invent, we're launching MLOps Lens, which essentially gives you a range of best practices on how to apply at a very detailed level. I'll give you an example, a very detailed level of an MLL's guidance, where it talks about the pillar, the specific question, the very, very precise implementation steps. Again, all of these are kind of double-clicked. I just took a snapshot of it over here, but each of this can be double-clicked to look at the best practices underneath every category for implementation. This is a performance efficiency pillar, but you have similar ones for sustainability, cost efficiency, and so on. And this gives you a good framework to think about, even if you think of a checklist or a questionnaire, to make sure you've covered every possible best practice in your implementation. If with Countdown Premium, it also sort of automates some of these best practices. So essentially, we build a bunch of tooling that will help you as a part of the AWS transform, which you saw earlier. You could trigger an assessment to tell you where you're at, how does your workload compare to best practice, and gives you a quick snapshot summary and number of activities that you need to do to get to best practice in a single dashboard. In addition to the transformation itself, the migration/transformation, Countdown also helps you during cutovers. Obviously, a moment of truth. When you finish your transformation, you're looking at moving to the new world, and that cutover could be always a tricky time. And with Countdown, essentially we offer automated alerting, automated alarms, which are set up for the key services in migration. Could obviously changes by the nature of migration. And we have engineers, essentially 24/7, a global team which is context aware, so understands the context of your workload and helps you sort of on a proactive basis by monitoring these workloads during that cutover period to make sure there's no interruption or any outages. And we also, in addition to the cutover support, the engagement offers you basically a summary of the event, of the cutover event, and potential opportunities for you to improve further beyond based on the observations we found during the cutover and the architecture assessment period. Cool. With that, I'm leaving a few additional resources which we discussed with the architecture, with the new launches around ML Lens and Gen AI Lens for you to sort of consider and refer beyond the session today. With that, I'd like to welcome the main act. If you've seen Coldplay or Maroon 5 concert, you always have an opening act and a main act, and now we have the main act today with Ajay.
Thanks, Amit. Good morning, everyone. Thanks for being here on Friday. I know this week has been filled with a lot of technical announcements, discussions, and sessions. And there is a lot of creative ideas that were discussed during this week. So I'm sure there was a lot of learning, as well as it was a lot of fun. I'm assuming you guys enjoyed yesterday evening's replay. Okay, before we move forward, let's do a quick show of hands. How many of you have received spam or scam calls in the last 1 month? Okay, good. So, okay, perfect. That's awesome. That's near real time now. Okay, so we know that spam and scam calls have impacted every consumer who uses telecommunications, which is basically almost everyone. And it has affected businesses and enterprises too at the same time. So what happens is when the legitimate calls from enterprises are sent to consumers don't pick up the call because they think this call is from somebody whom they don't know. So it affects both sides of the equation, the consumers as well as the businesses. This creates a distrust in the telecommunication and communication ecosystems. So here is a result of the survey done by TNS last year. 68% of contact center executives say spam or fraud calls has hurt their bottom line. So, because a lot of calls are made by businesses from contact centers. 88% know that somebody has been affected because of spoofing and maybe you got frauded or maybe because they tried to scam using the calls and social engineering. 96% of companies are looking for authentication and anti-spoofing solutions. So this is very well in line with what we see here, what you guys are facing. So authentication, trust, and identity in communications are the essential pillars, and more so over now. In the world where most of the communication is moving to IP, we have made it easier for people to make calls in bulk, and that creates another problem on the other end of the spectrum. Today we'll talk about what TNS is doing to combat this problem. Yeah, it's going to move to next. Today we're going to talk about what TNS is doing to combat this problem, working with AWS cloud migrations. Okay. With this, I'm going to introduce myself. I'm Ajay Gupta. I lead the technology and architecture for TNS, which is a Koch company on the communications group. I've been working in telecommunications for about 3 decades. I'm keen on using simple and secure architectures and solutions to solve real-world problems. I love playing pickleball. 2 months of experience doesn't mean that I'm good at it, but experience will help build it up. Okay, little bit introduction about TNS. TNS has been in the communication industry enabling mission-critical communication since 1990. TNS works in the back end in the sense that we sell services to carriers, and carriers provide those services to their customers. So that's why you don't see TNS name per se. You will see Verizon, AT&T, T-Mobile, and all the other large carriers. TNS operates in 21 countries with more than 1,300 employees and processes billions of transactions every year in 60 countries. Yeah. Within TNS communications, the mission is to protect subscribers, enterprises, and businesses from unwanted and fraudulent calls. TNS supports more than 120 million subscribers today in North America using Call Guardian. We protected about 19 billion calls in last 12 months, which were spam or scam. And we support almost probably slightly above 150 carriers in the network with our analytics. On the other end, TNS supports branded calling, which means businesses are able to reach their consumers. So TNS processed about 1 billion calls in last decade with branded calling. So this is the scale at which TNS operates. This scale brings challenges as well as opportunities. So it means there is lots of data that you get to look at, but at the same time, to process the data, get the data back to actionable intelligence is the challenge, and that too in real time, near real time. Today, consumers are facing multimodal attacks. Earlier, it used to be simple attacks. Now it is, you will get an email, you will get a text message, you will get a phone call, you will get a message on the social media to actually narrow down on which consumer they want to scam for money. So this is becoming more advanced. Just in last 1 month, one of the major US bank announced that 40% of their complaints are tied to spoofed calls. So you can imagine, major bank in US publicly saying 40% of their complaints are tied because their numbers are getting spoofed. So those are the areas which TNS is trying to protect. It's a systemic problem, global problem, and a growing problem. It starts with developed countries, starts moving to developing countries slowly, because as systems standards get built into developed nations. Okay. With show of hands, how many of you would pick up a call which just shows a number, which is not in your address book, or which is which provides a name of the business or which provides a name with the logo. So if the number is not in your address book, consumers have slowly tuned out and assumed that I'm not going to pick up the call because I don't know this number. If it shows up with a name, there is a sense of, okay, what is this call for, but you still can't trust it. But if it's logo, then consumers will trust it. It means somebody has validated things or verified things in the backend. Okay? So this is what the result shows. There is increased ability to connect both ends for the communication, whether it is business, whether it is residential, to make sure that if the receiving party understands what the call is for. Okay. Moving on. So how is this done today? There is something called call labeling. So when party A, consumer A calls party B, in the back end, we identify the telephone number, the history, reputation of the telephone number, and then combine it with the call. Based on the result of the reputation and scoring, the consumer is either given a warning or a name or branding information. Consumer has a choice to select, okay, if the call is, let's say, on a range of -4 to +4, if the score is -4, block the call, don't even ring my device. If the score is -2, it's a warning, I want to send it to voicemail. Okay? If it is positive, deliver it to my device. So consumers are given a choice as well as working with the algorithm and scoring mechanisms in the backend. Okay, now we are getting into a little bit into the platform. So TNS provides this kind of service to the platform called Call Guardian. Call Guardian is an industry-leading platform which uses cross-carrier data and events combined from multiple data sources to identify the reputation, assess the risk, and determine the call treatment. Okay. Each call is evaluated for number of signals. It can vary from few tens to few hundreds, which can be behavioral, network, historical, analytics indicators in tens of milliseconds before the call is delivered to the terminating device or the terminating subscriber. To support this, we migrated our on-prem solution to AWS Cloud. And as part of that, we went on a modernization journey with AWS. So we're going to talk a little bit about that. So there is one thing I want to mention here specifically. When the problems become as common as this problem is, standard, for example, whether it is FCC or ITF, they would formulate certain standards to make sure the whole industry is moving in the right direction. So there are standards which came out about 5-6 years ago, ITF standards, called stir-shaken standards. FCC has mandated that they have to be implemented by all carriers in US. Canada is adopting it. So there is an effort on the standard bodies to curb this problem. But even after this, there are a lot of cases where spam still happens today. So it has covered maybe 60-70% of the problem, most common use cases, but there are a lot of use cases which are not covered yet. So in order to modernize the platform, there were certain requirements. TNS Call Guardian platform processes more than few billion events a day, call events a day. So which means all the traffic which our network sees gets into the platform, which is being used to ingest, analyze, and derive intelligence out of it in near real time. So at a peak, TNS platform handles about 20,000 calls a second, where inference needs to be generated in real time within few tens of milliseconds. Because carrier wants to minimize the call hold time because it eats up their network resources. So that's the challenge we had in front of us when we were looking at migrating our on-prem platform to AWS cloud. Okay. So this is a preview of the platform. It uses different kinds of data, different volumes moving at different velocity into the platform. Signaling events are real time. There is industry sources of the data. Then you have crowdsourced feedback. Customers can give feedback into the system, which gets processed to make sure that calls are being scored correctly. And that inference is fed into the systems, which is used to process the calls. Okay. So here is a very simple view of the architecture that we put together. This architecture uses what some of the components Amit described earlier. Okay. One of the big differences that you will see, which is very different from on-prem. In on-prem, your compute is tied to your storage. Okay? You have to have a totally different way of thinking when you might move or migrate or modernize your platform moving into the cloud. Earlier on-prem, if I have to add, let's say, another data source, I will be adding new set of servers. Okay? Here, after the modernization and migration to cloud, yeah, you can just store the data in S3. Only thing is how much and by which mechanism do you want to process it. So the thinking changes completely when you start thinking about on-prem versus AWS. Okay? So we're going to talk about some of these things in a little bit detail here. So TNS in this architecture uses EMR HBase for low latency. When we started this journey, S3 backed HBase didn't cut the performance for us. So because the performance you need is in microseconds, and S3 is remote from that perspective. So we worked with the AWS team to come up with, start using EBS. And 2 years later on, AWS team came back with S3 Express. So that's the kind of things that you see, the challenges that you see, which are different in on-prem versus AWS cloud. But there are a lot of solutions and componentry available in AWS catalog, which you can use. The only thing is you need to make sure are you using the right thing to achieve the results that you want to achieve. Okay. We use Hive Spark S3 backed for large-scale analytics and resiliency, because for resiliency, not within the region, across the region, S3 makes it a lot easier for you to manage that. So you don't have to pay the price upfront when you're setting up your DR sites. Apache Druid for summarization and reporting. Customers expect, even if it is 20 billion records in your data store, they still expect less than 500 millisecond response time when they're pulling up a report on the portal, right? So you need to make sure that different use cases demands different tools to be used to meet the customer needs, or maybe in some cases exceed the customer expectations. Because writing a portal is simple, but when you write the portal with that kind of data in the back end, you have to take care of a lot of things, and you have to use purpose-built tools available. We use SageMaker for training the algorithm, do A/B testing to minimize false positives, false negatives, and measure the drift with data pipelines. So what Amit showed earlier, different accounts, we use Data Lake for data governance and security, where all the data is stored, but you can grant access based on the requirements which are tied to the use cases down to the table level, column level, and row level. That also helps us get to a stage where there is single source of truth, zero copy of the data. The data is stored in whichever platform needs to process it. Data lakes provides the access. Apart from this, integration with feedback sites and portal, which is probably regular use case, nothing unusual about it. So I'm going to skip some of these things so that we can go to the next one. I think one of the key things here is cost. When I say cost, on-prem, it is sunk-in cost. You already bought the hardware. Somebody is already operating it for you. You're already paying the price for your data center. Okay? But here, I'll give you a real example. We were looking to onboard a new customer on the platform. If it would have been on-prem, I would have said, OK, let's buy 10 more servers, buy it, get it racked in 2 data centers, bring it up, then start setting up the system. But here, OK, this is the volume. You do the sizing, and you turn on the switch. Right? Of course, it's not as simple. You have to work with the customer and all that stuff. But there is less effort on the regular tasks so that you can focus on the high-value tasks. That's the advantage you get for scalability and resiliency perspective from AWS Cloud. But that also means that the responsibility is on the user. Responsibility on the user means all the teams who are engaged into building, testing, deploying the platform. Because when you make things easier, it's very easy to shoot yourself in your own foot. Like spinning up 20 servers is just still a click away. So there needs to be a lot of guardrails, controls, and policies in place to make sure that the cost is not going out of the whack. Okay. So I'm going to talk a few things which I already touched upon, which is impact to date. Operational excellence, that part I didn't touch upon. I talked about the overall scale of the platform. That means different portion of the platform needs different care. Care means operational support, whether it is backup, whether it is patching, whether it is software upgrades, third-party software upgrades. All of these things have to happen almost on a daily basis, different portions of the systems. That is regular day-to-day work, and if you use managed services, you can offload that work so that your teams can now focus on building feature functionality, which your customers want, without focusing on the regular day-to-day work so that your teams can focus on the high-value work. So that's one of the things, learnings from migration and modernization journey. In addition, we used DMS and data sync, plus a lot of in-house tools for migration of all this data. A lot of data that was migrated is temporal in nature. If a call is a scam call today, it doesn't mean the same number cannot be a good number after 3 months down the road, right? So we had a lot of challenges in migrating this volume of data into cloud and running two platforms in parallel. We ran almost like 6 months plus of parallel operations, and at every step, we had to make sure that, yes, the results are the same. And that's where CDP comes in to help. If there is a problem and somebody understands the architecture, they're able to help you. So we worked with CDP and rest of the cloud support operations from AWS team hand in hand to make sure that parallel operation is successful. At the end of the day, do the cutover, still maintain it for rollback until another 3 months down the road, we're comfortable turning the on-prem systems down. Then I think one more thing which is very important is, in on-prem systems, usually the data is in vaults. There is even if you want to enable the use of the data across different portions of the organization, it is very difficult. You can create your own data lake on-prem as well, but scaling it using the same governance model is very hard. So this is another item which is the impact positively from our side, that it unlocked all the data that we had in different platforms. Now, today, it is very easy to make sure that, okay, product team wants to start looking at a new use case because we want to marry data from platform 1, platform 2, platform 3, because all the data is in the data lake. And you have governed secure access. Who can access what form of data? And you can even sort of hide what you don't want to share or encrypt the portions which you don't want to share to rest of the use cases. So this is another positive, very positive impact for the migration and modernization. The last piece which I want to touch upon, or maybe second last, all this data needs backup. And you have to be able to restore the backup when the day comes, right? Taking a backup of this amount of data is not an easy job, right? So this is another advantage, a positive impact for migration, that you set up the policies, the backup is happening. Yes, testing is still difficult, but you have the option to test, to restore the data by spinning up another environment to make sure that everything works. Because you don't want to be in a situation where you're taking the backup, but you cannot restore it. The last impact that I want to talk about is, I'm going to club time to market and innovation together. After the migration and on the modernization journey, right now, doing new proof of concepts is a lot easier and faster. I'll give you one example. We have an on-prem system which is in 2 sites. There's a new use case where you have to replicate data in real time. Okay? Now you buy a third-party product, or you bring in AWS Cloud services, which can help you do that by just writing API gateway and Lambda. Right? So I'm not saying it is production grade, but doing a POC is way faster so that you can fail fast. You can fine-tune it, okay, what do I going to do next stage to make it production ready, or what are the other options available? So that is a very good positive impact of when we went on this modernization journey, shorter time to market for features because you use IAC for everything. Spinning up your environment is a matter of days versus a matter of months where you have to buy servers. Positive impacts are good, but there are a lot of lessons learned too. Okay? There are 6 strategies for cloud migration. Rehosting, replatforming, most common ones. Other ones are for specific use cases. For our platform migration, it was a lift and shift. Initially thought of a lift and shift, but eventually it became lift and shift with a tinker. And tinker was pretty extensive. Okay? During migration, everybody expects the cost to be lower on day 1. Right? That's usually not the case if it is lift and shift. But you get functionality which you never had earlier, or we were sort of assuming that we have it, but it's not really there. One of the examples I gave you was backup and restore. Okay? Similarly, trying out things for observability, which means it collects all the data from all portions of your systems in one place, and being able to narrow down on the problem when it comes up. That's another case which you can utilize in this case, but on-prem you would have spent a lot of time. Now the challenge for us is part of the system is on-prem, part of the system is in AWS. How do you consolidate them together? So that's another lesson learned, that if the platform is going to be in a hybrid mode, how do you combine these two things to get a single pane view of the system? Because when there's a problem in production, you don't want to go around figuring out where the problem is. Okay? Now, initially the cost may be the same or probably higher. So you need to make sure that you're right-sizing the resources. There are some AWS tools available which you can use to figure out what we are using or what we are not using. Okay? What are the better options available in the cloud? Then whether you use reserved instances or do you get other savings plan, that's always a big thing. Failover and DR is the next one. You have to think of failover and DR in a totally different way in cloud. It's very difficult to test different scenarios in a failover DR situation. We were looking for tools, and finally, when we were starting the test, FIS tool was suggested by AWS team, which is fault injection tool. So you can bring down portions of the system and experiment before you do a full DR testing of your service. So that became very handy, but those are the lessons learned as part of the process that you can bring down a database. Without actually bringing down the database, you can add network latency, you can bring down access to S3. You can do a lot of things to make sure that your system service is ready to be tested for DR. Okay. Then there is one more thing which is important, which gets ignored a lot: getting the organization ready for cloud sensitivity. The hardest part is cloud adoption isn't just about technology. It is about people and processes. I'll give you one simple example. TNS has 24/7 NOCs all over the multiple regions in the world. Those NOCs are used to monitoring using existing tools. We migrated one service to AWS, but rest of the systems in different divisions are still working the same way. You have to think about how this is going to integrate in the existing processes, how your current people are going to get trained so that they are used to creating that muscle memory that now they have to support AWS systems. Okay. Then working closely with the cloud support teams. I gave you one example earlier about S3 Express. Similarly, another example that comes to mind is API gateway. When talking internally to another service, you need, in between that, you need NLB. Recently, it has been announced that now you don't need NLB for API gateway to talk directly to the Lambda. So there are enhancements which are happening, but those are the things you learn as part of the cycle. Some of the things may not sometimes make sense, but I'm assuming that feedback goes back and AWS takes action on those. Oh, sorry. What are the next steps? Cost optimization, auto-scaling. Auto-scaling different portions of the system because we're not 100% cloud native, right? Because it was lift and shift with Thinker. So this is one big task for our teams to go and see how we can modernize it to make it cloud native in more areas. Because without that, auto-scaling is less likely to help us. Moving some more services to containers, serverless, for faster release cycle, faster deployment. Automation, like I mentioned earlier, yes, we are automating it, we are testing the backups, but we want to make sure that it's happening automatically. Observability, we talked about already. Then I think two things which I took away from this reinvent for last 4 days, which is using Kiro for faster development and the 3 agents purpose-built agents to better our security posture, monitoring our security posture, as well as collecting all the data so that problems can be troubleshooted faster. Those are the two takeaways which we think are not here, but from the reInvent. Okay. Our partnership with AWS positions Call Guardian for the next, I won't even say decade, maybe less than a decade for innovation, moving forward for fraud detection, because things are going to evolve. The pace at which they're evolving is faster every year. So with this, thank you for joining. TNS journey is a great example of how AWS enables migrations, transformations. Working with their teams closely eases that journey. I won't say it's easy. I won't say it's a smooth journey, but it eases your journey a lot. We hope this gives you a meaningful insight into our journey, and if you have any questions, I'm open to answer. Thank you.